Hi guys, in this video we are continuing looking at writing electronic configuration and drawing the electron inbox or spin diagrams that represent the electronic configuration of the element. On my screen you're going to see the electronic configuration for argon already written in, and I'm going to use this in order to write our electronic configuration for elements with atomic numbers from 19 to 30. We'll be looking at the transition elements with atomic numbers 21 to 30, and I want to mention those as I call out the names of the elements from potassium to zinc. So just as a way to familiarize you with the names of the elements, I'm going to start from potassium. So we have potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. You are to familiarize yourself with the first 10 elements of the transition metal series, which is from scandium, atomic number 21, to zinc, atomic number 30. In this video, I'm also going to make reference to a fourth rule that I have added in on the right hand side in my list of rules. I'm going to read aloud what I have written, and I will explain it as we write our electronic configuration. It says a half-filled or completely filled D subshell is more stable than a partially filled D subshell. Right, by half filled, that means D5. Completely filled means D10. In writing out the electronic configuration, we will see what this means. So I'm going to start by jumping in and looking at the electronic configuration for potassium. So potassium is an element with one more electron than argon. So in an effort to just save some time in writing out the entire electronic configuration for argon, I'm just going to put the element itself in brackets here. So our 3p subshell is full. That means the electron which is in potassium, which orbital should it fill into? We would have expected it to fill into the 3d subshell. However, the 3d subshell is slightly higher in energy than the 4s. So our electron will fill into the 4s before it fills into the 3d. So that means that one electron will fill into the 4s subshell, where we have calcium. We have 2 electrons. These electrons are also going to fill into the 4s subshell, and this gives us our electronic configuration for calcium as electronic configuration for argon followed by 4s2. Let's look at scandium. All right, so we have argon, which will, and I'm just going to put argon. All right, I'm going to fill it in for the next 10 elements because we know it's expected to be filled, the orbitals from 1s to 3p. And I'm just going to show what happens to the 4s and the 3d subshell. So we are in or looking at scandium now. Our 4s subshell being full, right? In calcium, this means It's also going to be full in scandium. We have another electron to be added into our electronic configuration. It must then go into the 3D subshell. So this gives us 3D1. We would expect for titanium the same thing, 4s2, 3D2, vanadium 4s2, 3D3, and then we get to chromium where we'd expect it to be 4s2, 3D4. However, we're going to apply our rule here, which is the fourth rule. A half-filled D subshell, which is a D5 configuration, is more stable than a partially filled D subshell. So we have 4 electrons. This would be 4 electrons of equal spins. So instead of putting 4 electrons in our D subshell and 2 into our S subshell, the electrons will move around such that the D subshell becomes half filled, right? It is more stable than a partially filled D subshell. So 1 electron was taken from the 4s subshell. This leaves us with 1 in the 4s subshell. Right, so we would have expected 2. However, a half-filled D subshell is more stable than an incompletely or partially filled D subshell. Right, so this is one here to take note of. So let's look at manganese now. Right, so we have electrons filled up to the 3p subshell. That gives us 18. So we have 7 electrons to distribute between 4s and 3d. Our 4s subshell will fill with 2, and the 5 remaining electrons go into the d subshell. Right, so we have 4s2, 3d5. Let's continue. Right. So after 5, we're going to have 6 electrons in the D subshell, and 7, and then 8. And then we get to copper, where we would expect it to be 4s2, 3d9. However, we do have the opportunity here to create a completely filled D subshell, that is a D10 configuration. So that's exactly what we do. We take out an electron from the 4s level. This gives us 1. And the configuration would be 3d10 for copper. Right, and zinc would be as expected, 4s2, 3d10. So I'm just going to go back and highlight the 2 elements which were expected to try to learn off by heart. Alright, and that way it becomes easier to remember, which is that chromium is a 4s1, 3d5, and that copper is a 4s1, 3d10 electronic configuration. And the reason for this is because electrons will transfer out of the 4s orbital to create a half-filled, which is D5, or a completely filled, which is D10 subshell. And this is because this type of electronic configuration is more stable than a partially or incompletely filled D subshell. Right, so these are the electronic configurations for the first 10 elements of the transition metal series, and you're expected to know the atomic number for each element, their name, and how to write their electronic configuration.